First, we will discuss what is the cardinality and how you can reduce it. Thereafter, I'll be showing you the different methods of cardinality reduction, and then I'll be showing you how you can manage a reduced cardinality and the large cardinality in a data train test split. Then finally, I'll show you a categorical encoding, how you can do the categorical encoding, and then finally you can balance your train and test set in the term of its column. Thereafter, I'll show you these four classical machine learning algorithms and how you can test your high cardinality accuracies, ROC-AUC for training set and test set, and ROC-AUC for low cardinality training and test set. So this is going to be a very interesting lesson. Please subscribe and like this channel so that you can get updates directly into your inbox. So without wasting time, let's go ahead and get started with line by line coding of feature engineering for machine learning. Hello everyone, welcome to feature engineering for a machine learning. And this is going to be the another lesson on feature engineering series. And in this lesson, we are going to discuss about what is cardinality in machine learning. Cardinality is very important to understand. Cardinality may improve your accuracy and it can reduce the redundancy. But before that, let's go ahead and understand why this feature engineering is required. Suppose that you have a data and it has a lot of features. Alright, then if you want to reduce the number of features, you can do a feature selection. But suppose that you have a data and it do not have a much feature. The number of features are very limited and most of the features are encoded in some complex number. In that case, you have to manually extract those features, and the process of extracting those features is known as a feature engineering. There are many types of feature engineering like manual feature engineering and automatic feature engineering. In the most of the cases in the deep learning, features are automatically extracted from the dataset. Like in the image dataset, deep learning algorithms automatically extracts those features. But in the classical machine learning algorithms, you need to provide the dataset. Alright, that's mean the processed dataset which have a lot of the feature. In that case, we need the techniques or a tool of a feature engineering. Alright, so why we are going to study here the cardinality? The cardinality means the number of possible values that a feature can assume. For example, let's say if we talk about the planets in our solar system, so there are 8 planets in our solar system. That's mean a feature which name is the planets of a solar system can take up to 8 different values. But suppose that if we say that the total number of planets in the whole galaxy or in whole universe, then in that case it could be the millions and the billions. That's mean a single feature can take a millions and the billion values. That's mean if a single variable or a single column can take up so many values, that's mean there is high cardinality. But if values are limited and those values are small, then that's mean the cardinality is low. Alright, do you understand this? You can understand it like this. The total population, or you can say the name, alright. So the name of a whole world population could be the millions. Alright, the people are having different name, but few people are having same name. Alright, but at the same time, if we say that the gender of a person, alright, gender of a whole population of world can take either 2 or 3. Alright, it depends. Either male, female, either otherwise male, female and transgender. Alright, so let's go ahead and take just male and female. That's mean this value can take only the 2 values. That's mean that is the low cardinality. But if we say that the names of whole population, that is a huge, the millions of name could be unique names. Alright, perfect. So what is the problem of having high cardinality? So what do you see here in the difference? there. Let's say the whole population is having millions of unique names, and the whole population having only the two gender, male and the female. So if we divide our dataset into the two-part training and the test set, and there are millions of people who are having unique name, so there is very high possibility that few labels could be only present in the training set and could not be present in the test set. All right, and at the same time it could be like a few labels present only in the test set and not present in the training set. That means to say that a big number of labels within a variable may introduce noise and the overfit. And some labels may only be present in the training set data, and some only may be present in the test data set. And another issue with having high cardinality is variables with too many labels tend to dominate over those with only a few labels. That means the people having unique numbers will dominate over the genders, because the genders are having only the two variables, male and the female. Alright, so I'll make sure that it is pretty much clear at the end of this video series. So the first I'll discuss about in this lesson how to quantify cardinality, and then I'll show you the examples of high and the low cardinality. Thereafter, I'll show you what is the effect of cardinality while preparing our training and the test data set. And then finally, I'll show you the effect of high and the low cardinality by using machine learning algorithms, and then we will evaluate the performance of machine learning algorithms. Alright, so without wasting time, let's go ahead and get started with this lesson. So the first of all, I'm just gonna rerun. I mean, these are the pre-filled codes just for these two rows. So the first one is we are going to import necessary Python packages in our Jupyter notebook. So we are going to import here pandas, numpy and matplotlib. Thereafter, we are going to use these machine learning algorithms. Alright, these four type of machine learning algorithms to evaluate the machine learning model performance. Thereafter, I'll be evaluating these machine learning model performance over the Roc Auc score. Now what do you see there? I have not used any accuracy F1 score etc, but I'm going to use here ROC and AUC score. Alright, so ROC AUC score is used when you have unbalanced data set, and there is fairly very high chance that if you have a large number of cardinality, that's mean high cardinality, then your data set will be mostly unbalanced. So that's why we are going to use here Roc Auc score, and this Roc Auc score is a good measure of model performance in this case. Thereafter, finally, I'm going to import here train test split, and this is going to be imported from sklearn.model selection. Alright, let's go ahead and run this. Thereafter, in the second step, I'm going to read a data set, and the very famous data set, and we all are aware of this data set, a Titanic data set. The Titanic data set is a universal data set, and this is the perfect example which you can use almost in any kind of algorithms and machine learning. That's why we play around with this Titanic data set a lot. Alright, the way this Titanic data set is, we can use this data set in so many ways to evaluate our model performance. Like we can use this Titanic as a base example. Alright, our base data set, you can say. Let's go ahead and read this data set. Do remember, this data set is available at my GitHub repository. The name of GitHub repository is all CSV ML data files download. Alright, that's the name of CSV. That's the name of the repository. You can see this. Let me show you just a second. Alright, so you can see this one. Lakshmi made it. All CSV ML data files download. And inside this, you will see there a titanic.csv. Then click on this titanic.csv. Thereafter, you will get something like this. But we are going to read it like a raw format, like this one. Alright. And then from here, you can get this copy from here. Thereafter, you will see there, this is available here. All right, perfect, superb. All right, just a second, I wanted to copy this one, I think. Sorry, yeah, so this is already available, so there, I don't need to recopy it again. All right, so we have our data set, and this data set is having so many rows, so many columns, like a passenger ID, survived, passenger class, name, sex, age, sibling and spouse, there is parents and the child, there is a ticket number, and then we have their fare, cabin and embarked. All right, so basically we are going to evaluate here two column, that's the cabin and sex column. All right, so because I'm just going to show you here a cardinality example, and based on only these two columns I'll show you how, if you reduce the cardinality of the data set, your accuracy improves drastically. Do remember, I'm not going to use all of these columns. Just for the sake of example, in this video series, I'm gonna use sex and cabin column. This is the two column, because this cabin column is an example of high cardinality and the sex is an example of low cardinality. All right, perfect. So these two columns I'll be using there. Let's go ahead and get these columns. All right, so the first of all, few things we need to know, that the cardinality. The cardinality means the total number of values, a column can take. That means the total number of unique values. All right. So I have here this data. Let's go ahead and make this data as a name of df. That would be much better. Otherwise, okay, let's go ahead and make it only the data, not an issue. All right, so we have here a data, and in this data, the first of all, I'm gonna say here this name, how many unique values in this name. All right, so this name is also having a lot of unique values. All right, so to understand how much unique values are there, we are gonna use the length of these unique values. It says that we have total 891. But before that, let's go ahead and see what is the shape of this data. The shape of data is this one. That's mean every passenger have their unique name. That's mean the cardinality for this column is extremely high. And at the same time, let's go ahead and check. Let me copy this one. All right, so let's go ahead and check the cardinality of sex. Definitely their cardinality is only 2. Let's go ahead and check it for a ticket. All right, so in the case of tickets, we have 681. All right, perfect. Now let's go ahead and check in the case of cabin. So in the case of cabin, we are having high cardinality, that is 148. And we are going to take only this cabin and the sex. So the cabin is high cardinality dataset and sex is low cardinality dataset. I'll show you an example, method. I'll show you a method how you can reduce the cardinality of this cabin column. All right, superb. So let's go ahead and try to understand that how we can do this one. So the first of all, I'm gonna just take this data is equal to data, and in that case, I'm just gonna take here this cabin and sex. All right, perfect. Now if you see this data is having only two columns, that is the cabin and another one is sex. All right, so this cabin is having 148 unique values. That's mean high cardinality, and sex is having only 2 unique values, male and female. All right, so the first of all, what we are going to do here, we are going to reduce the cardinality of this Kevin by just assigning some numbers to these Kevin numbers. Now if you notice that the Kevin numbers here starts with the C, B, A, B, C, D like this one. So that means that the Kevin and Kevin categorization like the ABCD, and thereafter their number 1, 2, 3, 4 like that is saying that if I say that the C1 and the C2, that means the C1 and the C2 are nearby. C3, C4, 5, so those are the nearby, and there is the B1, B2, B3, B5. Alright, so like this one. So in this case, to reduce the cardinality, we are going to combine all C Kevin together, and all those C Kevin we are going to put that in C. All B Kevins we are going to put that in B like this one. Alright, so all A will be placed in A, B, C, D like this one. Super. So that's the perfect example to reduce the cardinality. And in that case, so what I can do here, I can say that like this one. Kevin dot str, all right, and there is 0. So if you do like this one, what will happen there? That means this column is being converted into the str, and thereafter we are also going to get this NEN number. All right, so there are two ways to do that. Either we first convert it into a string, and thereafter we get the first character of these Kevins, that's mean ABC like this one. Thereafter, if you do like this unique, you will get this one A, B, C, D, E, F and T. All right, so what I'm going to do, I'm going to fill this NEN with N. All right, that's mean I'm just gonna put it here for your simplicity. All right, just run this one, and thereafter I'm saying here fill NA with N. So in that case, all the NA values have been filled with N, and now if we put here this unique, we get like this NCEBCD like this one. All right, perfect. Now we need to map this in this data set. All right, that's mean this data. In that way, in that case, we need to do like this one. Kevin underscore reduced is equal to data. All right, I mean to say that we are going to just get all those things. All right, now if you see this data, this Kevin is reduced, that's mean the cardinality of Kevin column has been reduced in Kevin reduced column. All right, perfect. Now let's go ahead and check the cardinality of these all these three columns. So I'm going to say here data dot unique. I have to provide here this data Kevin dot unique. In fact, that should be the length there. That's the 148, and at the same time I do here Kevin reduced. It's not reduced, it actually reduced. All right, sorry, is it wrong? No, it was correct. Oh, sorry, their spelling was yeah. So now you see the Kevin is having 148 cardinality, that's pretty much high cardinality, and Kevin reduced is having only the 9 cardinality, that's in the low cardinality. So what I wanted to tell you at the start of this lesson is that if you reduce the cardinality of a data set, there is a fair chance that you will improve your algorithms. And I'll definitely show you, you will get low accuracy if you use this k-bin data directly, but you will get high accuracy if you use this k-bin reduced data. All right. And at the same time, I'm also gonna put here, I think for the sex here, definitely we know that there is only 2. All right. So, all right. So we'll be using the combination of k-bin and sex. That's mean 148 and 2. And then I'll be showing you how you can improve the accuracy if you use the combination of only 9 and 2. All right. Perfect. Superb. This is how you know that you can improve these things. Let's go ahead and discuss this problem. Let me show you. So I told you that here, what are the problems? So as I told you that, I'll show you the overfit problem. All right, so this problem, if you use a high cardinality data set, that will be overfit. And if you use low cardinality data set, that will not be overfitted and it will produce high accuracy. Now I'm going to show you an example of this one. Labels may be only present in the training data set and not in the test data set, and so on. That means to say that if we divide this k-bin data set in the training and the test set, there is high chance that few labels may be only present in the test set and not present in the training set. All right. So gonna use here train test split. All right. Perfect. All right. So now what I'm going to use there, I'm going to just simply use xtrain and xtest, ytrain. There is ytest. All right, is equal to train test split. And in this train test split, I'm going to use this data. All right, whole data. I think I have just missed one thing. I should not have missed that one because this data is having only these data. All right, I mean, which we are going to use as an input, a feature vector. We do not have a target vector. That means I need to come back here. I need to run this data so that I can get everything in the data and rerun these things, not an issue. And yes, here instead of this k-bin 6, I need to get one more, that is the survived. All right, so this survived will be used. This survived will be used as the target variable. All right, perfect. So k-bin 6 and the survived. Superb. Let's rerun all those things so that we can get that one, this survived column. All right, perfect. So train test data, and what are the columns which we are going to use as an input feature? Those are k-bin underscore reduced. Thereafter we have there a sex. All right. All right, so that's going to be used as an input feature. Thereafter I'm going to use here as a target variable. That one is survived. All right. Thereafter I'm going to use here test size of the data. I'm going to use here a huge data. All right, around the 40% of the data. All right. Thereafter I'm going to just use here random state. All right, random state I'm going to use here 0. All right, superb. Let's go ahead and run this one. Thereafter, if you check here the xtrain and the xtest shape, you will get something like this one. A training data set we are sorry, this is a 40, not this is 0.40. All right, so there we get the training dataset size is 534 and test dataset is 357. All right, so I'm you might notice here is that I'm not using whole data as a training data. I'm just using a 60% of the data as a training data, and the rest of the 40% data is being used as the test data. So high cardinality leads to uneven distribution of categories in the training set and test set. When a variable has a high cardinality, often some categories lands only in the training set or only in the testing set. If present only in the training set, they may lead to overfitting. If present on the testing set, the machine learning algorithm will not know how to handle them as it has not seen them during the training. So we'll find some number of labels in the k-bin which are present only in the training set and not present in the test set data. All right. So for that one, we need to first get the unique number of k-bin data set, all right, from the test and from the trained data. So how we can do that? How we can make that like this? Test k-bin unique is equal to x underscore test. Thereafter we have this k-bin and then there is unique. All right, so these are the unique the k-bin data set which is present in the test set. All right, similarly I'm gonna do for the train as well. So train k-bin unique, thereafter I'm gonna just make here a train. All right, I'm just gonna put it here after a comma. That's mean this one saying that these are the unique numbers which are present only in the training set and these are present only in the test set. Visually we can identify that there are more number of labels present in the training set and not present in the test set. That's mean these are going to create a problem. All right. Let's go ahead and see exactly how many present there and how many are not present there. All right. So we cannot do like a simple subtraction to identify that how many and how many, even though we can do that one, but that is not exactly the way to find out that how many is present there in the test set and not present in the training set. All right. Otherwise we can simply do like this one. Let's say length of train k-bin unique minus test k-bin unique. All right, this one is actually length. Sorry, that should not be there, and there it should be. All right, so it says that there are total 35 columns, I mean less present in the test k-bin. All right, 35 total. There are number of 35 columns. Now let's go ahead and find out those unique numbers which are not present. All right. So to find out those unique numbers, we can simply say that like this one. So we are gonna make here a list. All right. For x in train k-bin unique. All right. That's when we are gonna iterate this train k-bin unique one by one, and then we are going to get all those labels which are not present in the test. All right, for x in train k-bin unique, if x not in test k-bin unique. All right, and if it is not there, then put that x here. That's mean it is going to produce all those columns which are not present there. All right, that's mean these are the length of columns which are not present there in the training set. All right. Perfect. Let's go ahead and get the length of this one. So it says that there are total 80 columns. All right. So there are total 80 columns, unique values, which is present in the training set but not present in the test cabin set. All right. Perfect. Now similarly, let's go ahead and see how many are present in the test set but not present in the training set. All right. So we can simply just copy this one and paste it here. Now we are gonna iterate over test set. All right. So test cabin unique, if not in train cabin unique. All right. That's when it is now saying that there are total 45. All right. So there are total 45 rows. 45 unique values which are present in the test set but not present in the training set. So these things are gonna create a problem when you train your algorithm with high cardinality. That is why it is recommended to reduce. These things. All right. Now let's go ahead and find out in cabin reduced. All right. So these are in cabin unique, but these are not in the cabin reduced. So let's go ahead and find out in cabin reduced. Let's cabin, and now I'm saying that cabin reduced. All right. Let's go ahead and paste it here. Now I'm gonna say here x underscore train. Thereafter I'm just gonna put here this cabin reduced dot unique. All right. And that is also going to be here, but for a test data set. All right. That's mean that is going to be for the test data set. So it says that there is only one column. All right. That's mean if we operate it on cabin reduced, that's mean that is the mapped column with reduced cardinality. This one cabin reduced, that is the reduced cardinality. It has only one missing value which is not present in test data. All right, but it is present in the training data. That's mean it might be overfit problem, but algorithm will run. When algorithm does not run, if a new label is present in the test set and that is not present in the training set, that's create a problem. All right, let's go ahead and see it with another direction like this one. Now we are gonna do it for x test and x train. All right, so in that way it says that all the columns which are present in the test set is present in the training set. Now do you notice here one thing? There is a huge difference if we reduce the cardinality of the data. All right, so this one is with high cardinality, but this one is with low cardinality, and low cardinality is always preferable. All right, perfect. Now what we are going to do, now I'm going to show you how you can train your algorithm machine learning models. All right, now I'm going to show you how you can train your machine learning models to understand that how these models are performing. All right, how good these models are performing. All right, so let's go ahead, do first of all categorical encoding. All right, so we need to do a categorical encoding. I'll tell you why it is required. Let's say we have our this data, and in this data what we have here, we have all these. Now do you notice that we have these numbers as these are not numerical number first of all, and these are text number, And apart from that, the survived column, and there is sex column, male and female. All right, so these are also a text column, and this column has to be in numerical data, and this text data will be converted into the categorical encoding, because these columns are categorical column, and we need to convert these columns in a categorical encoding. All right, so the train test split, we already have done that one. So X train, there is X train and X test. So we'll be using, what are the columns which we are going to use? We are going to use first the combination of k-bin and the sex, and then the combination of k-bin reduced and the sex. All right, but in this k-bin, if you notice that it has high cardinality, and there are most of the numbers are non numbers, and you can find that is null dot sum. So it says that in the training set we have around 407. All right, there are total 407 values which are null, and x underscore test, all right, is null dot sum. So it says that we have here as well total 280 values as a null. All right, so see here, currently we are not focusing about the filling null values, but we are focusing only in the reduction of a categorical in reduction of high cardinality data. So in this case, what I'm going to do here, in this case, I am going to fill all these null values. All right, so I'm just going to fill all these null values with 0. All right, but there is one issue here. The problem is, all right, I think it's there is no issue, so we are going to just fill these. All right, so x underscore train dot fill na. All right, so I'm gonna just fill those with 0, and that I'm going to fill it with 0 numeric the string data. All right, and then in place is equal to true. That's mean it will be filled at its place itself, and thereafter we have here x underscore test dot fill na in place. All right, now everything is on place, and now if you can check that there is no null values. All right, and there is no null values for test data as well. All right, so no null values. Perfect, superb. So everything is on place once it is done, and all the null values are filled. Let's go ahead and start this categorical encoding. Now we are going to just see once again this X train data. So these X train data is having this kind of the data. Now how we are going to do this categorical encoding? This is pretty much simple. In the way we are going to do, we are going to use here pandas data frame get dummies. All right, and there we are gonna say here X train. All right, so as soon as you do that one, you will get there all these columns. All these columns are categorically encoded for all number of rows. All right, do you see there? Sex, male, female, etc. So all these have been encoded. All right, superb. I mean, this is great. All right, so get dummies for X train, and similarly we can do for X test as well. All right. Perfect. So let's go ahead and first do few things here. Currently we are taking all k-bin reduced and the sex data together, but we will make here only the two combination. The first combination is going to be k-bin All right, the first combination is going to be Kevin and 6. All right, and another one is going to be Kevin reduced. All right, and then it is going to be a 6 as well. All right, so we are going to use these two combination. All right, perfect. So for these two combination, we have to first get this Kevin 6 and thereafter Kevin reduced 6. All right, so just for a simplicity, I'm just gonna provide here Kevin and 6. All right, so I can say they are the columns on which I want to operate, and those are Kevin and the 6. And now you have just got total 72 columns. All right, and this one is on test set, but at the same time, if you do for the train set, you have got total 107 columns. All right. Do you notice here one extra column, that is the Kevin reduced, which we do not want? That's when we are also going to select that one here. And do remember, we need to put this into a 2 square bracket. All right, perfect. Now you get this one. We do not have Kevin reduced, and this one I'm going to say that as a training data. Thereafter we have here this test data. All right, this one X test columns. So this is going to work like this one. We have our train data and we have our test data as well. Let's go ahead and check the shape of train data and test data. What's the shape there? Currently we have shape of 106 and 71 for training and the test data. Now the problem is here, if you notice that all the columns are not present in the test set. That means the number of columns are mismatching, which is in training but not in the testing. And in that case, this is going to create a problem during the training. And to reduce this problem, there is another set of code which will balance the column of training and the test set. All right. Perfect. So we are going to balance the columns of a training set and test set. So the first of all, we need to get that what are the missing columns. All right, so what are the missing columns which is present in the train set but not in the test set? So I'm going to say here the train dot columns, test dot columns. Once you get that one, you will notice there you have got these missing columns. So these columns are missing. All right. So for that one, for C in missing columns, I'm gonna fill those missing column in the test set. All right. Test C is equal to 0. And once we get that one, then we are gonna say here test is equal to test and train dot columns. So this line will ensure that we get only those columns which is present in the training set, will get those in the test set. That means now if you check the train dot shape and test dot shape, these should be same. And yes, those are same. Training set is having 106 column and test set is also having their 106 column. All right, perfect. Let's go ahead and build a sample algorithm to train our model. If you remember, we have imported these 4 algorithms: logistic regression, AdaBoost, random forest, and gradient boosting classifier. All right. So what I'm going to do here, I'm going to just create a random forest. All right, random forest classifier. In that, I'm going to provide their number of estimator, which is 200, and then random state is equal to just 42. Thereafter CLF dot fit, and in that we have training data set, and Y train we already have. So in that way it is going to train, and training is extremely fast. Thereafter I'm going to say here Y train probability. All right, in fact it's predicted, Y train predicted, CLF dot predict underscore probability. You might ask that why we are predicting the Y train. If we should test on Y test. Yes, we will test with Y test as well. All right. So there we have a predict probability X underscore test. All right. So we have a training set and a test set, Y train and Y test. It says that could not convert string to float. All right. That means to say that there is a string and which could not be converted into a float. Let me see which one is having this string. It says that the very first row, all right, is having that problem, X train. Sorry, that should be actually train. That was the mistake. All right, that's the train and test. Once you got their Y train pred and Y test pred, you see there was no requirement to get this Y train, and I'm getting this Y train pred to understand that what is the accuracy achieved on the training set and what is the accuracy achieved on the test set. That is why I'm getting the prediction for these two data set. All right, let's go ahead and see this Y train pred. So what do you get? This Y train pred is a column, is a list of list, and this list is saying that what is the probability of classification of 0 and 1, 0, 1, 0, 1. All right, that's when person has survived, a person does not survive, person survive, person does not survive, person survive. So these are the probabilistic estimation. And this one does not survive and this one is for survive. And if this survival is greater than 0.5, that means there is high chance that person has survived. And if it is less than 0.5, that means if this is less than 0.5, then it will be greater than 0.5, which is equivalent to 0 and 1. All right, because we have the columns in our survived 0 and 1. All right, so if 1, that means person has survived. If 0, that doesn't survive. That means to say that if we estimate for this column number 1, that says that it is actually column number 2. So for this column number 2, which is present at index 1, if this value is high, that means survival rate is high. If this value is low, that means the survival chance is pretty much low. So we will consider only the second column for our ROC AUC score. Let's go ahead and calculate the ROC AUC score. I say there the print, all right, train set, and then I say there print. I'm going to provide there ROC AUC. All right, so this one is corresponding to the classifier name which I'm going to use there. Thereafter ROC AUC score. So basically I'm going to use here a format. All right, so in this we have here a random forest ROC AUC score, and in the ROC AUC score I have here Y underscore train, Y underscore train predicted, and then I'm going to just take the second column there. All right, So this is going to be the ROC AUC for a training set, and at the same time I'm also gonna get the ROC AUC for the test set. All right, so that's the Y test, and this one is going to be like this one. And if I run this one, it says that found input variable with inconsistent number of samples. Let me test it, not an issue. Just a second. Let me see which one is creating a problem. So it says that the first one is creating a problem. All right, I think the problem is here. So that should be this one. All right, get all the rows of a first column. All right, so I had done some testing offline, although I haven't changed any code, just I'm changing these two. All right, so you will see here a difference as well because I had done some testing offline. All right, so it says that we have got 87% of accuracy on the training set and 82% on the test set. That means this is huge underfit. All right, so this data is underfitting and it's not overfitting. All right, so this one is only for this cabin, that's mean which had high cardinality. All right, if you notice that I had selected this cabin which had high cardinality. All right, so if you want to test it for low cardinality and high cardinality as well, along with other 4 types of algorithm, for that one I'm just going to take a little more time to build a perfect machine learning model iterator so that we can train for high cardinality and the low cardinality as well as for all algorithms. All right, I just wanted to show you how we will be building the algorithms. All right, perfect. Now a true ML model building is going to be here. So the first of all, I'm gonna say here def run underscore models. In that I'm gonna say here this data train, there is data test, y underscore train, there is y underscore test. All right, thereafter I'm gonna say here rf is equal to random forest classifier, and then we have number of estimator is equal to 200. Thereafter we have here a random state which is 42. All right, then we have here add a boost. Add a boost is add a boost classifier, and number of estimators here we have is equal to 200, and then we have here a random state is equal to 42. Thereafter we have here a logistic regression which is logit, a logistic regression, and then we have a solver is equal to LBGF. All right, LBFGS, that's the solver which we are gonna use there. And then we have here a random state. This random state is going to be once again 42. Thereafter we have here a gradient boost classifier, that's going to be like this one, gradient boosting classifier, and that one is also having number of estimator as 300 and random state is equal to 42. Thereafter I'm gonna create here a models dictionary, and in this dictionary I'm gonna provide first of all random forest. All right, so this random forest is going to be rf. Thereafter another one is add a boost. All right, this add a boost is ADA. Thereafter we have here logistic regression, and this logistic regression is having this logit, and then finally we have here this gradient boost, that's the GBC. All right, Thereafter this model dictionary, I'm gonna get the train data set. All right, if you remember there, we have used to get the train data set, where is it? Here. All right, do you see there? Something like this one. All right, so we are gonna repeat all these process here inside a function, and it will be easy for us to train for all these algorithms at one time. All right, so the train is equal to pd dot get dummies, and in that I'm gonna put here data train. Thereafter the columns for this one I'm gonna use here a data dot, sorry, it's going to be the data train dot columns. Now how would we get this data? We will get there data train, data test, y train and y test. All right, so we'll pass there a data train separately, data test separately, y train, y test, and we will be passing those here to get the encoded training data set. All right, that's mean this is going to be a categorical encoding. All right, super. At the same time we are going to get for the test, that's the pd dot get dummies data underscore test set. All right, so we have there columns is equal to data underscore test. All right, columns. All right, thereafter I have here this missing columns is equal to set of this train dot columns minus set of test dot columns. All right, now if you remember there, I'm gonna just use this method. All right, so these methods I'm gonna use once I get that one, and then I'm just gonna put this one here, and after this for loop we need to make sure that the test data set and the training data set columns are same. All right, in that case this is going to be like this one. All right, perfect. We have got the train data set, test data set. Thereafter for label clf in models dot items. All right, because this models we have already built that one here, and this one is a dictionary, we are going to iterate over each of these algorithms. Label clf in model in models dot item. Thereafter we have here clf dot fit, then we have here this train y underscore train. All right, there we have this train comma y underscore train. Thereafter we have y underscore train pred. All right, is equal to clf dot predict underscore probabilities of training data set, and then y underscore test underscore pred is equal to clf dot predict underscore probability of the test data set. All right, superb. Now once we have got this one, and then we have reached in the final stage of this lesson where we are going to print these things. All right, superb. I'm just gonna say here testing for, and at that place I'm just gonna put something like this, and I'm gonna just remove these. All right, the testing for the name of clf is actually label. All right, so this label, thereafter this one, and then it's gonna say here the train ROC AUC. I'm just gonna remove this one. All right, and it says that there is test ROC AUC. All right, and then it says that there is print. All right, perfect. Let's go ahead and run this one. It says that we have some mistake somewhere. Let me see. First of all, this is going to be a boost, and then like this one. All right, superb. Let's go ahead and get our X train dataset columns. What are the columns which we have currently? Currently, we have these three columns: cabin, cabin reduced, and sex column. So the first of all, I'm going to take the combination of cabin and the sex. Then I'll show you how you can improve the accuracy using cabin reduced and sex. All right, so we have here run models. In that, I'm just going to use here calls is equal to, first I'm going to use this cabin and sex. There you have here this calls, X train calls, X test calls, thereafter Y underscore train, Y underscore test. All right, let's go ahead and run it. It says that it random classifier object has no attribute predict probability. Just a second, let me see what's going to be wrong here. CLF dot predict. Let me see what was this one. It's probabilities. All right, proba. All right, A is missing there perhaps. Yes. All right, now we are running it. It says that we have got these accuracy for random forest. We are getting training, this one, and testing is there. Training for AdaBoost, logistic for training and testing is almost similar. And we are getting for a gradient boost, a high training and low testing. So all these algorithms are saying that our model is underfitting in the case of high cardinality, because this one is an example of high cardinality. All right, let's go ahead and take the examples of low cardinality. In case of low cardinality, where we have cabin underscore reduced. All right, let's go ahead and run this one and see how much accuracy we are getting. So in this cabin reduced, if you notice that our model is not overfitting. All right, and we are getting almost a competitive. All right, we are getting almost a competitive accuracy in case of cabin reduced. That's mean low cardinality. And this is the great thing about the high cardinality and low cardinality. I'm sure you have learned a lot in this lesson, how you can improve your machine learning models by using the techniques of cardinality management. You can change the high cardinality variables or columns in low cardinality models, then convert it into a categorical encoding, and then run your algorithm for a better performance. Superb. So this is all about in this lesson. Thanks a lot for watching it. I'll see you next lesson.